So, good morning, students. Let's now learn the conversion of the fractions into decimals, types of decimals, and then conversion of decimals into fractions according to our grade 9. Okay, in earlier classes also we were doing, but here we will be studying how to convert a non-terminating decimal into a fraction. But before that, we need to learn a few other things. So as you see, these fractions 2 by 7, 5 by 8, 8 by 9, 5 by 6, 7 by 15, 5 by 16, 8 by 25, 7 over 100, 3 over 7, 123.40. So before proceeding further, you should also convert them into the decimals on your paper, right? I hope you have done already. So now let us observe them. See, many decimals are non-terminating. 2 over 7 is not terminating. It is not terminating. It is moving on, moving on, moving on, and it's just continuing. 8 over 9 is also not terminating. 5 over 8 is terminating. Right, when we are dividing 5 with 8, it finishes here, then there will be zeros only. Now 7 over 15, this is also not terminating, this is also continuing. Now 5.16, this is terminating, this finishes here. When we are dividing 5 with 16, you will see it finishes here, the remainder comes out to be 0. Now 8.25, it finishes with just 2 decimal places. Then 7 over 100, it also finishes with just 2 decimal places. 3 over 7, it never finishes. It is non-terminating. This, when we are dividing with 40, it is finishing. So first thing, you know very well, what is the name given to these decimals? These are non-terminating decimals. This is a non-terminating decimal. So I'll underline with them uh, with the pink color, all of them, this one, that is there, this one, and this one. These are all you say non-terminating decimals. All right, you write on your page. On your page, you also write on non-terminating decimals. But the name is not just non-terminating decimals. Non-terminating decimals. But these are not just non-terminating. You see 285714, 285714, 285714. So this can be written as like this: 0.285714 bar on the top. Similarly, here if you see here, this is again a non-terminating decimal, and what is repeating? See, 0.8, but 3 is repeating. So we can write it like 0.83 bar. You also write on your paper like this. Now you try writing this, and try writing this also in the bar form. So these are repeating decimals also. This is repeating, 3 is repeating, here 8 is repeating. Here you can write on 0.8 bar because 8 is repeating. So the full name of the decimal is repeating non-terminating decimals. Non-terminating repeating decimals. We can write here, let me write with another color, non-terminating repeating decimals. Repeating, you understood? Now let us come to the other category. If you see another category here, see these are the terminating decimals. 1, here 2, this is 3, this is 4. These 4 decimals are terminating decimals. They terminate, they finish. Now why are they terminating? What is the special character? Why is 5 over 8 is converting into a terminating decimal? Why 5.16 is converting into a terminating decimal? Similarly, 8.25 is converting into terminating decimal. Similarly, 7 over 100 it is converting into terminating decimal. There is a special reason. See, here we are dividing 5 with 8. So if you take factors of 8, prime factors, they are 2 into 2 into 2. Let us consider next terminating decimal, 16. So if you take factors of 16, they are 2 into 2 into 2 into 2. Now if you are taking this next terminating decimal, 25, take factors of 25. You see the factors, prime factors are 5 and 5. Similarly, here 7 over 100. So if you do the prime factorization of 100, it is 2 into 2 into 5 into 5. So what is special? See here, the factors of the denominator are 2 and 5 only. Here the factors of denominator are 5 only. Here the factors of 16 are 2 only. Here the factors of 8 are having 2 only. So this is the special character. So if in the denominator there are 2 and 5 only as the factors, 2 and 5 only as the factors, the decimal conversion will be the terminating decimal. I hope you understood. If in the denominator, if in the prime factorization of denominator, the factors are in the form of 2 and 5 only, nothing else is there in the factors of the denominator. No 3 is there, no 7 is there. Alright, in that case, the decimal conversion will be a terminating decimal. So now I hope you can solve question number 1 of this exercise 1.3. Now let us move on to the next concept. Here we are learning how to convert a terminating decimal. This is a repeating non-terminating decimal. Repeating non-terminating decimal. In the previous classes in 5th grade, in 6th grade, we have been learning to convert the terminating decimal into P over Q form. But here in this class, we are learning how to convert a non-terminating repeating decimal. Non-terminating repeating decimal into the P over Q form. So let us see the name once again. Non-terminating repeating decimal. So we will now learn the reverse. Like here we learned how to convert 5.6 in this form. Then we converted 7.15 in this form. Now we shall learn how can we convert this back into 7.15. How can we convert this back into 5.16? So let us move on. Okay, ready? Okay, so here we proceed like this. Students, you have to take care of the format. First of all, the is equal to should always come in the center. Is equal to. So we start like this. let x be equal to this. We are taking it as x. So in the next step, or we are expanding this. 5 6 bar means 5 6 bar bar. 5 6 time and again. 3 times writing is sufficient. Now here comes the first step. Now you will name this as equation number 1. Students, actually you should solve this on your page along with me simultaneously. That is how the learning happens. So here we are naming this as equation number 1 when after writing the repeated digits in the repeated form. Now what is it being repeated? 5 and 6 only. So 5 and 6 is only repeating. Now what is our next purpose? Our next aim is to bring this decimal to this place. We need to take these one set of the repeating digits. We need to take one set, only one set. What is the set of repeating digits? 5 6. So we need to take one set of 5 6 before decimal. They should go before decimal. 5 and 6. That means we have to bring the decimal here. So how many places we need to move the decimal? 1 and 2. That means we need to multiply with 100. So let us write down multiplying with 100 comma we get. So 100 into x, 100x. And here decimal goes to this place. So here we are getting 256.56. Let us write one more time 56, because it is unlimited times. 5 6 5 6 5 6 5 6 5 6. So what we did, we wrote 5 6 3 times. Here also 5 6 was 3 times. Now let us name this as equation number 2. Students, what next we need to do? We need to subtract this equation. So we need to subtract this equation from this. How shall we write? Subtracting 2 from 1 comma we get. My students, see, my school, my class students, I want you to solve this exactly in this format. First of all, you see, all the is equal to should be in line. All the is equal to should be in line. Mine was a little deviated. So subtracting question number 2 from 1. So 100x minus 1x is 99x. Now here 256 minus 2. 256 minus 2 is 254. I repeat, 256 minus 2 is 254. Or let me do it for you here. 256.565656. And we are subtracting 2.565656. So this is 0, this is 0. All this is 0. 6 minus 2, 4, then 5, then 2. So hence this is 254.0. So I just rubbed off all that. Now we are having very simple thing, 254.0, or we can write on 254 only. Now it is easy. This implies x is equal to 254 over 99. 99 dividing both sides by 99. See if any cutting is possible. No cutting is possible. So this is how we have converted. Therefore 2.56 bar is equal to 254 over 99. So this is how we converted. Students, what are the special things to be observed here? You see all the decimals are in line. Can you see that? Now if you see, I have written let or this implies, therefore they are also in one line. This is how you need to do. Then at last I have written the answer in the final form. This is important. So before moving further, you will solve you will convert 2 3 numbers of this type into p over q form before moving further. I repeat, before moving further, you will convert 2 3 such numbers into p over q form. Then let us learn next type. Here you see that bar is on 4 only. Bar is on 4 only. There is no bar upon 2 and 3. So let us learn how to do this. Let x is equal to 5.234 bar, or now we shall do, we shall bring, first of all, see, let us not do this step. First of all, let us bring these number 2 3 before decimal. 2 3 should come before decimal. That means the decimal should come to this point. And how that can come? You say we have to multiply with 2 zeros. These are 2 digits, so we have to multiply with 2 zeros. If it is 1 digit only, we will multiply with 1 zero only. So we are multiplying with 100 so that this decimal comes here. So or 100x, we have multiplied with 100. So decimal is coming here. So we have got now 523.4 bar. Okay, now let us expand bar. 523.444, 3 times is sufficient, and let us name this as equation number 1. Now as we discussed in the previous question, rest is same. Now we shall bring one of the repeated digit sets, just one set before the decimal. So here set has only one digit. In the last question, the set of repeated digits was having 2 digits, 5 and 6. There were 2 digits. That is why we multiplied with 100. But here only there is only one digit which is being repeated. So we will multiply with 1 0 only. That means we will multiply with 10 only. So multiplying with 10 we get, so 100 into 10, 1000x. Here also the decimal will go to this place. So decimal is coming here. So we are writing 4 4 4 4 4. So we can write as many times as we wish, but 3 times is sufficient. So let us name this equation as 2. Right? Now again the same process as we have learnt, we shall subtract this from this. So subtracting 2 from 1 we get, not 2 from 1, 1 from 2. 1 from 2 we get. In the previous paper also I had a mistake. We have to write on subtracting 1 from 2. We have to write on subtracting 1 from 2 in the previous problem. So here we are subtracting 1 from 2. 1000 minus 100. 1000 minus 100 gives you 900. Now here from this we are subtracting this 5 2 3 4 minus 5 2 3. So you see what will be there. So it is like this, 523.444. We are subtracting like this. So for this is 0, this minus this is 0, 4 minus 3 1, 3 minus 2 1, 2 here 12, 7 this. Or let us not write on 0. Now we can take 900 also to that side. Or now let us write on the original number, four 711 over 900, and see if any cutting is possible. Can we reduce this? I think there is no possibility of reduction, so this will be the final form. If cutting is possible, you have to do the cutting, but here again the cutting is not possible, so this is the final form. Right, students? Now you should practice at least 10 problems, 5 of that type and 5 of this type. Thank you.